Question 7, have a go. So for part A, we've got to show that something can be written in the form of this, where it's got sin squared x's and sin x's, no longer having any cos squared x's. So our opening thing is just to replace this cos squared x. Now what do we know? We know sine squared x plus cos squared x equals 1, and rearranging that, 1 minus sine squared x is the same as cos squared x. So we just substitute this in place of this. So on our right hand side we've got 1 minus 4, which is minus 3, and a minus sine squared x. Now turning this into a quadratic equation, taking all of this on the right over to the left hand side by adding 3 and adding sine squared x to both sides, we get 4 sine squared x plus 7 sine x plus 3 equals 0, which is what we've been asked to show. Now for part B, we've been asked to solve this. Now remember, this here is what we had at the top, which can be written in this form. So we've got to solve this, but instead we can solve this. Now this is a straightforward quadratic equation, okay, which needs to be solved. It can be solved by factorizing. I do that over here. So if you're not comfortable with how to factorize a quadratic equation, follow this bit in purple. So we end up with this pair of brackets here. So for that to equal 0, either the first bracket's got to be 0 or this second bracket's got to be 0. So with this bracket here, rearranging this, we get sine x equals minus 3/4. So our first solution we get from inverse sine minus 3/4, which is minus 48.6. Equally over here, our solutions come from sine x equals minus 1, so inverse sine minus 1, giving us our opening solution on the calculator of minus 90. Now both of these calculator solutions are outside our required range of between 0 and 360. All our solutions have to be between 0 and 360. So using all silver toy cars on this first one, we've got sine x being negative. So where is sine x negative? Well, that's here in the third and the fourth quartiles. So going around, our first solution is at 180 plus 48.6, 228.6, and our second solution is all the way around here, which is 360 minus 48.6, which is 311.4. Now with this sine minus our solution being minus 90, I think when we have a solution exactly on a boundary, we're better off just thinking straight back to the normal sine curve. Here's the sine curve. There's our first solution at minus 90. Here's our next solution at 270. So so our three solutions are 228.6, 270 and 311.4.